Okay, we're going to take a look at some SAT questions here. These are all relating to exponents. So for the first question here, we have if x squared equals y cubed, for what value of z does x to the power of 3z equal y to the 9? Well, if we know that y cubed is equal to x squared, then y cubed would be equal to x squared cubed, which means that y to the power 9 is going to equal x to the power 6. But that is also equal to x to the power 3z, right? And the reason for that is we know that y cubed is equal to x to the power 3z, but we've also proved that it's equal to x to the power 6. So therefore, x to the power 3z equals x to the power 6. Same bases, you can drop the exponents, divide by 3, and you get z is 2. Let's take a look at another. So for this one here, we have 2 to the power of x plus 3 minus 2 to the x is k times 2 to the x. And we got to find that k value here. So how would we approach this? Well, I know 2 to the x plus 3 minus 2 to the x. I can rewrite as 2 to the x times 2 to the 3 minus 2 to the x. Again, the reason for that is when you multiply with the same base, you can add those exponents together here. So now, if you take a look here, what we have here is 2 to the power of 3 is 8. So that's really 8 times 2 to the power of x minus, you really have here 1 times 2 to the power of x. Now, I have 8 of these minus 1 of these is going to leave me with 7 of these. But again, what is 2 to the power of x plus 3 minus 2 to the x equal to? I had shown that this was equal to k times 2 to the x. So therefore, these will cancel, and you get k is 7. Let's try another. So for this problem here, we have the square root of x times the square root of x is equal to x to the a. The thing with this one here is to remember that the square root in general, the square root of x, is actually x to the power of a half. So if someone writes the square root of x times root of x, I know here that's going to be the square root of x times x to the power of a half. Well, that x is really just the power of 1. Now I'm multiplying with the same base. I add the exponents. So 1 plus a half is 3 halves. And you continue on in this manner here. So in this case here, we've got here, this will be x to the 3 halves to the half. And power to power you multiply, this is x to the 3 quarters. But like I said, they set this equal to x to the a. So the exponents must equal, and we get a is 3 quarters. Let's try another. So for this one here, you have x is greater than 0. In the equation 2 times root x plus 2 equals 3 root x. So you're solving a radical equation. What you want to do here to start yourself off is to square both sides of the equation. By squaring both sides of the equation, you get rid of those radicals. So when I square 2, it applies to both products here. So this will be 2 squared is 4, and this will just be x plus 2. Right, that goes away. 3 squared is 9, and the root of 2 squared is 2. This becomes 4x plus 8 is 18. 4x is 10. X is 10 over 4, and reducing that, x is just 5 over 2 here. All right, let's try another. So for this one here, you have x to the power of ac times x to the power of bc is x to the power of 30. You know x has to be greater than 1, and a and b sum to 5. Find the value of c. Okay, well, x to the ac times x to the bc, you're multiplying at the same base. You add your exponents. Now you'll notice here, I can factor out a c out of this thing. I have a plus b, but I know that in this case here, a plus b equals 5. So therefore, we know that this is equal to x times 5c. But now they told us in the question that this is also equal to x to the power of 30. So now again, the same situation, right? You have the same base, so you can equate the exponents here. So in this case here, you get 30 equals 5c. Divide across by 5, you get c equals 6. All right, let's try another. So for this one here, we have n cubed equals x, and n to the power of 4 equals 20x. Find the value of x. So for this question here, I want to find the value of x. How do we handle this? Well, what do I know? I know if I take n to the power 4 divided by n to the power 3, that's going to be 20x divided by x, which is going to be 20. But I know that n to the power 4 divided by n power 3 is just n. So now I know that n equals 20. But if n equals 20, I know that x is equal to n cubed. Therefore, x is equal to 20 cubed. Therefore, x is going to equal 8,000. So for this one here, we want to find the value of xy. Same sort of trick. Notice that x times y is just equal to x to the 8 times y to the 7 over x to the 7 times y to the 6, right? Because when you divide with the same base, you subtract the exponents. But I know that this is going to equal 333 divided by 3, which is 111. Okay, that concludes SAT questions for exponents. You can see it's just the very similar questions on the same three basic rules, right? Multiply with the same base, you add the exponents. Divide with the same base, you subtract the exponents. Power to a power, you multiply. So all of these problems, it's the same idea. They're just adjusting those rules and having you apply those rules and solve for particular variables. So study these examples. Subscribe to my YouTube page for more. Thank you.